Hi guys, welcome back to my YouTube channel. In today's video, we will understand a very important topic, which is L'Hopital's rule. So L'Hopital's, some people try to pronounce it like Hopital's rule, whatever that. So whatever way you're comfortable pronouncing it. So I, usually say it like L'Hopital. So we'll understand the L'Hopital's rule. So what is L'Hopital's rule? Basically, if you're trying to figure out limits, अगर आप limits निकालने की कोशिश कर रहे हो and you get a indeterminate form. So let's say something like 0 by 0 form or infinity by infinity form, plus infinity, minus infinity form. So you are not able to find the limit when you have a fraction. So you have like when you have fx divided by gx and you try to figure out limit and you're not able to move ahead because of some form which is not determined. So how do you go about that? That is what we will be dealing with this in this particular video. So L'Hopital rule helps us to do that limit in a easy manner. So that will be the agenda for this video. So without wasting any more time here and there, let's get started. All right, so let's try and understand the rationale and what is basically the problem that we are dealing with. हम किस problem के साथ deal कर रहे हैं and ये सब चीज करने की need क्या है, ठीक है? So let's say you go on to find a limit, ठीक है? You go on to find a limit. So you have a function fx which is divided by a function gx. So मान लो ये एक expression है. Let's say this is an expression that you have and your goal is to find the limit as x is tending to some value a. This a could be infinity, this a could be some number, anything, okay? So let's say you have to find this particular limit, okay? So usually how do you decide limit? Limit basically means as your x value is getting closer and closer to this number, where is this expression going? So x की value जब a के नजदीक जाते जा रही है, तो ये जो expression है fx by gx, where is this reaching? ठीक है? That is what your goal is. So how do we usually go ahead? हम value put करते हैं. We just put the value of x equals to a and try to figure out what the number is going to be, right? But there are some situations in which we might have a situation like this. When you put this value a in this function, then you might have a 0 value. And then, same thing if you do here, you again have a 0 value, okay? So it's like saying that I have a 0 by 0 form. So 0 by 0 का actually कोई meaning नहीं होता. It's something which doesn't have a meaning. So we'll just, use inverted commas to represent it. And we'll just call it that this is an we'll just call it indeterminate form. So indeterminate form of 0 by 0. ठीक है, 0 by 0 form आ गई है हमारे पास. We are not able to determine. So indeterminate form basically means, the limit cannot be found. Okay. Limit cannot be found. You might have a indeterminate form of some different format, which is like, you might get something like infinity by infinity or, minus infinity by infinity, something like that. All these are also indeterminate form. Okay. So what if you have a situation like this? Then how do you go about finding the limit, right? Because the moment you have 0 by 0, then what is your limit? How do you decide that? Okay. So just to give you a little bit of recap, we did a lecture on limits previously. So I'll just give a link for that video in the description. So if you remember, we did what is the limit of a function as x is tending to 4. And what was that function? That function was x square minus 16 divided by 4 under root x minus 8. Okay. So now you see, if you try to figure out this limit, what do you get? If you put 4 here, you get 16 minus 16, which is 0. And if you put 4 here, you get under root of 4 is 2. So 4 into 2 is 8. 8 minus 8 is 0. So again, you get a 0 by 0 form. So हमने किस तरीके से लिमिट निकाली थी इस पर्टिकुलर केस में? So we used a result, कि अगर आपके पास एक फंक्शन है fx, let's say if this is your function, and अगर आपके पास एक फंक्शन है gx, और ये दोनों फंक्शन हर जगह पे सेम वैल्यू लेते हैं एक्सेप्ट फॉर वन पर्टिकुलर वैल्यू विच इज 4, ठीक है। तो अगर आप जो आपका नया फंक्शन है gx उस पे जो लिमिट निकालोगे वही लिमिट होगी जो इस फंक्शन की लिमिट होगी, ठीक है। सो वी यूज दैट रिजल्ट एंड ट्राई टू do some manipulations with this and figure out the limit. So what did we do basically? हमने क्या किया था, अगर हमें ये लिमिट निकालनी है then we used to do what? You can just take 4 common here and then you have root x minus 2 and then if you expand it, so this is let's say a square minus b square. What is a square minus b square? A plus b into a minus b. So a plus b into a, sorry, this will be x plus 4 into x minus 4. Okay, so this is the elaboration that we did, and then we said okay, I can divide and multiply up by a same number in the numerator and denominator. Then we did what? We divided by under root x plus 2 and we also multiplied by the same number, and then we tried to see that okay, what is this becoming. So we see that this becomes what? X plus 4, x minus 4 under root of x plus 2 divided by 4. You multiply these two, you get what? X minus 4 basically, right? Because this is a minus b into a plus b, which is a square minus b square. So x square, under root x square, which is x minus 2 square, which is 4. So abhi tak, till now, this function is exactly this function, right? But when you just remove this, then you get a different function, okay? So what we can do using that result, ki, if you have two functions which are exactly the same except for one particular value where you're finding your limit, so you can use the same function to find the limit. So we do this, and then what do we have? We have to find this limit x plus 4 under root x plus 2 divided by 4. Okay, and then you have to find limit x tending to 4. So now when you put x equals to 4, what do you get? You get, 4 plus 4 is 8 and under root of 4 is 2. So 2 plus 2 is 4 divided by 4. So this limit that you get is nothing but 8. Okay, so that is basically the entire, logic or chain of steps that we were using to find this limit. Okay. So is there any easy way? Is there any easy way to deal with such cases, right? Ya fir har bar we'll have to multiply it, and try to figure out some other ways. So L'Hopital rule tries to simplify this problem for you. Okay. So it's like, it's saying that, when you get a 0 by 0 form, how do you proceed to find this limit? That is the idea. Okay. So let's try and understand what is the rule and when can you apply this particular rule and what are the things that you have to be careful about. Okay. So let's see. So L'Hopital's rule, so, without getting too much into detail, I'll just try to put the result and, what are the things that you need to take care of. Okay. So what does L'Hopital's rule is saying? It says, let's say you have a function. Let's say, if you have function, if f and g, let's say you have these two functions and they are differentiable at x equals to a. Okay, so you have two functions f and g, and let's say they are differentiable at a point x equals to a. Okay, and that's where basically you want to figure out your limit. Okay, and what is the condition that you have? That when you find fa value, you get 0, and you find ga value, you get 0, because L'Hopital's rule can only be applied when you have a fa divided by ga. That should be 0 by 0 form. Okay, if you have such a situation, then what happens? And there is one more thing that you have to be careful about. And g prime a is not equal to 0. So whatever differentiation that you do for this function, its differentiation value at a should not be equal to 0. Okay, if that is the case, if all of these conditions are being satisfied, then then what can you say? Then you can say that, your goal is to find the limit as x tends to a for this particular expression, right? So this limit is going to be the same as you finding this limit. You finding this particular expression, f prime a divided by g prime a. So what is the rule saying? Let's understand that once again. So अगर आपके पास एक function है f and g, so you have two functions f and g, and they are differentiable at a point where you're trying to figure out your limit. Okay, that is the rule. And then, you see, your value at x equals to a for both f and g are 0 and 0. So you get a 0 by 0 form if you try to put this value here. Okay, so you have that complication. So you see, unless you have that complication, you should not be applying this rule. Okay, so this rule is specifically can be applied only when this is the case. Okay, so when you do that, and you know that g prime a is not equal to 0, then a very simple way of finding this limit is nothing but you differentiate your functions, okay, individually. आपको इसको differentiate नहीं करना है. So it's not like u by v format में आप differentiation करने लग जाओ. No. You have to differentiate this separately and then differentiate this separately and then find that value at x equals to a. So whatever you get by doing that will be your limit of this particular expression at x equals to, as your x value is tending to a. So that will be your limit. Okay. So this is basically your L'Hopital's rule. So this particular rule, this version of this L'Hopital's rule that we have studied right now, it's, ये थोड़ा सा restricted है. It is a little restricted, but I'll tell you another version of L'Hopital's rule itself, which is a little, gives you a little bit of more freedom. Okay. So when I say more freedom, meaning थोड़े और relaxed conditions में भी you can apply this particular rule in a more weaker conditions as well. Okay, so यहाँ पे we have put up lots of strong conditions like, okay, it should be differentiable at a, it should have 0 by 0 only, it should be not equal to 0 and all of that. Okay, so let's try to see this version of L'Hopital's rule first. Okay, so considering and taking this example again. Okay, so we see that, okay, this is my function fx and this is my function, let's say gx. Okay, I try to figure out my limit at x equals to 4. Okay, so I see that, okay, this is 0 and this is also 0 when x value is 4, right? So my f of 4 is 0, my g of 4 is also 0, right? And is this function differentiable at x equals to 4? Yes, it's a polynomial function, it's a quadratic function, it's differentiable. And if I see this is also differentiable at x equals to 4. Both of them are differentiable. So both functions are differentiable at x equals to a, right? And let's see the differentiation and see whether this condition is being satisfied or not. If this condition is being satisfied and you have to find this limit, you don't have to do anything, just simply do the differentiation and put the values and get the result. Okay, so that is what we are going to do. So let's see, let's do that. So limit x tends to 4, x square minus 16 divided by 4 under root x minus 8. Okay, so this is my function fx, and if you have to do f prime x, what are you going to get? This is x square minus 16, so your differentiation should be 2x. Okay, this is your function gx. If you do g prime x, what are you going to get? So g prime x. Okay, so this is 4, it remains as it is. This is x raised to the power 1 by 2. 1 by 2 comes in front. 1 by 2 minus 1 minus 1 by 2. So basically you will have what? 4 into x raised to the power minus 1 by 2. And there is a 1 by 2 also getting multiplied. Okay, so this will be nothing but 2 and x raised to the power minus 1 by 2. That will be your differentiation. Okay, so we just have to check one thing, that at x equals to 4, is this value equal to 0 or not equal to 0? So if you put 4 here, what do you get? So this is actually 2 over under root x. So if you put 4 here, what do you get? Under root of 4 is 2. So 2 by 2 is 1. So this is not equal to 0. So you can apply L'Hopital's rule. Okay. So how do you apply L'Hopital's rule? So this limit that you want to figure out, this is nothing but you just have to do this differentiation at 4 and this differentiation at 4 again. So you do what? 2 times 4 divided by, this is 2 into, root x. So root of x is 4 here. Okay. So if you try to find this, you get what? 4 into under root 4 is 2, and then you get 8. And that is exactly the same limit that we got previously by using, by using this particular formula as well. This particular entire, steps as well. We got 8, and using this step also we got 8. Okay. So whenever you have a situation, जब भी आपके पास एक ऐसी situation है wherein you have a 0 by 0 form, और आपके जो functions हैं वो properly differentiable हैं, then you can simply do the differentiation at the limit that you want. The only thing that you have to care about is क्या ऐसा तो नहीं है. Okay. First thing, to be able to apply L'Hopital's rule, you should have a 0 by 0 form. That is the requirement. ठीक है. And then you have to check whether your function is differentiable or not. Okay. They should be differentiable. If they are, just check कि कहीं ऐसा तो नहीं हो रहा है कि this is equals to 0. Okay. Because if it is 0, then, again, you are in that trap. Okay. So that should not be the case. So this again becomes not defined if that is 0. So that's something that you have to be careful about. Okay. All right. What if you are in a situation that, आपने ये किया, you did this, okay, and then somehow again you are getting a 0 by 0 form. So this also turned out to be 0 and this also turned out to be 0. It could very well be the case. There could be cases wherein, if you differentiate your function and you try to find this, you again get a 0 by 0 form. So if that happens, then what do? Then simply you have to do nothing. You can just take it one step forward and do the entire process again. What do I mean by doing the entire process again? So now you just differentiate this again. So you do f double prime, find a, and then you do g double prime, and then find the value at a. So again, this step you have to continue doing, and you will get exactly whatever is your limit going to be. Okay. So a note here that, suppose you get a 0 by 0 form after you apply L'Hopital's rule. Okay, once after you apply L'Hopital's rule once, you get again 0 by 0 form. Then what do you have to do? Then you can just differentiate. Your entire expression one more time. Differentiate one more time. And find the limit. Okay, that's what you have to do. So if something like this happens that, okay, this is, this again turns out to be 0 by 0 format, then you do what? Differentiate this function again. So you do f double prime and then find the value at a, and then do g double prime and then find the value at a. And whatever this value is, that will be basically your limit. Okay, so this is something that you can keep in mind as a side note, if you have ever be in a situation like that. Okay, there are two things that you have to note here. Sometimes students tend to make mistakes here, which is first thing is, be very careful when you apply L'Hopital's rule. Sometimes it might appear that you are getting a 0 by 0 form, but actually it's not a 0 by 0 form. It's just that apne, you have not simplified your functions properly. Okay, so in those cases also sometimes, students try to apply L'Hopital's rule, wherein actually your function is not in a 0 by 0 format. It's just that, you have not simplified your function. And then when it's not a 0 by 0 form and you try to apply L'Hopital's rule, it will tend to give you wrong results. So you have to be careful whether are you in a situation wherein you can apply L'Hopital's rule or not. So that is the first thing. Be careful if L'Hopital's rule can be applied or not. Okay. So let's say as an example for this particular note, you see, suppose, okay, so मान लो as an example, let's say, you are trying to figure out limit as x is tending to 1 and आप किस चीज का limit निकाल रहे हो? You are trying to find the limit for 2x plus 3, okay, and divided by 4x minus 2, okay. So, ideally, if you just put the values here, what do you see? If you put x equals to 1 here, you get what? This should be 1. So 2 into 1 plus 3, which is 5, divided by 4 minus 2, which is 2. So you should get 5 by 2, right? So it's not like you're getting a 0 by 0 form and you're applying L'Hopital's rule, right? But sometimes, student just see a limit and see that, okay, it's a fraction. So क्या करेंगे? Directly बस L'Hopital's rule apply कर देंगे और differentiate कर देंगे. So when you differentiate this, what do you get? 2x differentiation is 2. And then when you differentiate this, what do you get? 4x differentiation is 4. So what will seem like the limit? The limit will seem like 1 by 2. But actually the limit is not that. Limit is what? 5 by 2. You can simply put this value here and figure it out. Okay. So you have to be careful whether L'Hopital's rule can be applied or not. So you have to check all these conditions. Okay. So that you are in such a situation. Okay. And all of this is happening. Only then you can try and apply L'Hopital's rule here. Okay. The second thing is, you are finding limit of fx divided by gx. So the differentiation that you have to do, you have to differentiate f separately and g separately. It's not like कि ये एक function है और आप इसका differentiation करने लग गए. Okay. This is not what you have to do. You have to differentiate it separately, f prime x, and then divide by g prime x, and then find the value at whatever point you're trying to find the limit at. Okay. It's not like this is one expression and then you just do a differentiation and then just put the value. That is not what we are doing. Okay. So that is something that you have to be careful about. And this is also, something that you should keep in mind that, okay, whether you're applicable to apply L'Hopital's rule or not. Okay. So these are the two things that you have to be careful about. Along with that, अभी जो हमने L'Hopital's rule का statement पढ़ा है, that seems a little, it's fine, but L'Hopital's rule is valid in even, more general cases. So what are those cases? Let's try and see that. Okay. So और भी general cases के लिए it can be applied. So it can be applied in even more general situations. So what are those situations? Let's try and understand that. So यहाँ पे, here we said, okay, when you find the limit, you find your differentiation at A, you find your differentiation at G. So L'Hopital rule, the more general version says, your function doesn't even need to be differentiable at these points. Okay. So let's try and see what that version is saying. So that version says, that suppose you have f and g function and they are differentiable. They are differentiable in an interval alpha comma beta. So this is an interval जिसमें आपके function f and g, they are differentiable. Okay. Around a. Okay. So this is basically an interval around a. So like this is point A, and around a, this is an interval of alpha and beta. Okay. So there is an interval alpha comma beta around a. Your function f and g are differentiable in that interval. Okay. But except possibly at A. So, it can very well happen that your function is not differentiable at A. Okay. So all we are asking is, please, all that I need to apply L'Hopital's rule is कि मेरा जो function है f and g, they should just be differentiable in an interval around point A. Even if they're not differentiable at A, I'm fine with that. So even then I can apply my L'Hopital's rule. So previously we said, you have to find your function. It should be differentiable, and it should be differentiable at A also. That's why you're figuring out f prime A and g prime A. So that was a stricter version of it. The more general version says we don't care if your function is differentiable at A or not. All I need to worry about is whether in an interval around this point these two functions are differentiable or not. If that is the case, it's fine. Agar aapka function differentiable hai, then well and good. Then you can just apply the normal one. Then even if it's not differentiable, it's fine. All I need is it should be differentiable in an interval around point A. Okay. If that is the case, then and suppose we should be able to apply L'Hopital's rule. So what should happen? We should have a 0/0 form. Okay. And suppose fx and gx both tend to 0 as x tends to A. So this basically means, you should be in a situation to apply L'Hopital's rule. So if this is the case, and this is happening that, okay, whenever x is tending to A, both your function values are tending to 0. Okay. If that is the case, and, if g prime x is not equal to 0 for all the values of x, which is not equal to A in alpha comma beta. So this statement basically means if your g function, which was differentiable in this interval, so in every point in this interval, this g function should not be equal to 0. If that is the case, okay, then what can we say? So that is the first condition. Okay, if that is the case, and if you get f prime x and g prime x, and then if you try to find the limit as x tends to A, if this limit turns out to be L, okay, this limit value is L. So why are we doing this? Basically, we don't know whether function is differentiable at A or not. So agar A pe differentiable hota, so we could have just done f prime A divided by g prime A, right? But now it's not. So that's why we are talking about limit and not the actual value. Okay. So we are saying agar aapka g function ka differentiation is not 0 at any point except for A pe ho sakta hai, we don't know. But, and along with that, when you differentiate these two functions, okay, and you try to find the limit of differentiating these, you get a limit L. So when all of this is the case, then what do we say? That if your goal is to find the limit as x tends to A for fx divided by gx, so this is essentially the same as finding the limit of x tending to A f prime x and g prime x. And since this limit is equals to L, so it should be equal to L. Okay. This L could be a finite number. This L also could be infinite. This L could also be negative infinite. Okay. So it could be finite or infinite or negative infinite. Okay. Some of you might say, yahi to kiya tha. Yahi to last time bhi to kiya tha. This is exactly what we did last time also. Some of you might think that. But you see what is the difference here? Yahan pe, to figure out this limit, you are not doing this. You are not doing this. In this case, we might even have the case that, function is not even differentiable at A. So f prime A and g prime A, you don't even know that. What is that value? So even then it's possible to find the limit using this version of L'Hopital's rule. So what do? Just find the differentiation and then take the limit. Take the limit as x is tending to a. And that is basically what will be your limit value for this particular expression. Okay. So this is this is a more general version of L'Hopital's rule. कि अगर आपका function differentiable है, then तो this limit is nothing but f prime a divided by g prime a only, right? So that becomes the previous version only. Okay. So this is a more general version. Allows a little bit more flexibility also. Okay. All right. Turned out to be a little bit technical. Okay. Are there any other details that you need to take care of? Are there any other important notes that you can take? So first thing is, ये जो L'Hopital's rule है, this is applicable in general. So like, you might want to apply the limit as x is tending to a. A could be a finite number. Sometimes you might have some intervals a to b. Okay. So what if you want to apply, because, it's a closed interval. Okay. And you want to find the limit at point A. So you can only reach A from one side. So ये जो rule है, L'Hopital's rule, this can also be applied like this, right? So like only because, you're trying to figure out the limit at A. So, and there is no scope of going leftwards. So this rule can be exactly applied when you're trying to find limits like these also, right hand limit, left hand limit. Then also this L'Hopital's rule is applicable. Okay. This is applicable when you're trying to figure out left hand limit also. This is applicable when you're trying to figure out limit as x is tending to infinity also, as x is tending to negative infinity also. So L'Hopital's rule is very general. It can be applied in multiple situations. Okay. Along with that, what else, what more can you do using L'Hopital's rule? Which is, we said that, okay, you can apply L'Hopital's rule only when it has a 0/0 form. But it is not limited to this. Even if you get an infinite by infinite case or a negative infinite by infinite case, even then it is applicable. So like you can get any general case of this version. Okay. There also L'Hopital's rule is applied. Okay. So abhi, the entire discussion that we had was around 0/0, but it is equally applicable in all such scenarios also. Okay. So let's say, you want to figure out this limit that it is tending to infinity, 1 minus 3x squared divided by 5x squared plus x minus, okay, it is plus x. So let's say you want to find this limit. Okay. So सबसे पहला step to figure out whether you can apply L'Hopital's rule is not, whether you are getting an indeterminate form or not. 0/0, infinite by infinite. What form are you getting? Okay. So when you try to put infinite here, infinite square is infinite, negative of an infinite square is, so this will be negative infinity. Okay. You see, 5 times infinite square is infinite, plus infinite is infinite, minus 1 is also infinite. So it's a negative infinity by infinity form, right? It's a negative infinity by infinity form. So, this is a perfect case wherein we can apply L'Hopital's rule. Okay. So in such situation also you can apply L'Hopital's rule. So now how do you go about it? So you can just differentiate these functions and then try to figure out the limit. So differentiate this function. What do you get? Minus 6x divided by, if you differentiate it, what do you get? 10x plus 1. That is what you get. Okay. And then you just have to find this limit as x is tending to infinity. Okay. So अगर आप ये limit find करने की कोशिश करोगे, अब, some people might say कि, okay, this is also again infinite by infinite case. But think carefully now. Can you manipulate it and see, if you divide both sides by, like divide numerator and denominator by x, what do you get? Minus 6 divided by 10 plus 1 by x. And now if you find limit as x is tending to infinity, what do you see? this number will converge to 0. This is 6 and this is 10. So what is your limit going to be? Minus 6 by 10. Okay. That is how you can figure out your limit. Okay. So L'Hopital's rule is equally applicable when you are in such a situation as well. Okay. So widely applicable hai, and you can use it like that only. Okay. So that's how you can do it. And there could be cases wherein it might seem ki, यहाँ पे कैसे L'Hopital rule लग रहा है. But if you try and manipulate things, you might see that yes, there are cases wherein it might not seem very obvious to apply L'Hopital's rule, but it's actually easier to do that. So you see, let's say if you have an example like this. So let's say you have to find limit as x is tending to infinity, and you have x power 5 minus x power 4, and this entire thing is raised to the power 1 by 5, and then you have a x. Okay. So if you, apply infinite, so infinite power 5 minus infinite power 4, it's infinite raised to the power 1 by 5 minus infinite. So we basically know actually what is happening, right? In this case, there is nothing which is divided. So it might not seem very, very obvious that, okay, how can we apply L'Hopital's rule here? So you might try to do some manipulations to make it to that form. Okay. So if you see, if I take x power 5 common from here, what do I get? X power 5 and then 1 minus 1 by x, right? And this entire thing is raised to the power 1 by 5, and there is a minus x here. And then I have to find the limit as x is tending to infinity. Okay. So this is x power 5. Ye power jo hai, it can be separated, right? So you get what? X power 5, power 1 by 5. You get x. And this is multiplied by 1 minus 1 over 1 minus x raised to the power 1 by 5 minus x. This is what you get, right? This is what you have. And then you have to find a limit as x is tending to infinity. Okay. So now we can see that, okay, if you take x common, what happens? You take x common, you have 1 minus 1 by x raised to the power 1 by 5 minus 1. Okay. Can I bring it down here? If I do that, what do I get? So I get 1 minus 1 by x raised to the power 1 by 5 minus 1. This is first thing. And then if this is divided by 1 by x, this is essentially what will happen. It will go up, and it's exactly the same expression. And then you try and figure out what is the limit as x is tending to infinity, right? So here I see as x is tending to infinity, what is happening? 1 by x will tend to 0. So this number is 1 raised to the power 1 by 5, which is 1. 1 minus 1, it's 0. And then 1 by x is also tending to 0 as x is tending to infinity. So I have a 0 by 0 form here, right? So now to this form, I can apply L'Hopital's rule, okay? So sometimes it might not seem very obvious at the first instance, but ho sakta hai ki if you do the appropriate manipulations, you can apply L'Hopital's rule, because otherwise, it would have been very difficult to find the limit, because, everything is tending to infinity. You're subtracting from infinity, taking power to the infinity and all of that. Okay. So that's how you can go about it. I would love to know. I've told you how to go about it. So this is your fx function and this is your gx function. Now you have to apply L'Hopital's rule here. How do you apply L'Hopital's rule? Just differentiate them and then take the limit as x is tending to infinity. So let me know in the comments what is your answer to this particular question. And, I'd be happy to answer whether you have done it correctly or not. Okay. All right. So, guys, I think that's it for this particular video. There's one more topic which is left from this particular, implications of continuity and differentiability, which is the inverse functions kya hote hain, what is inverse function and what is the inverse function theorem. So we will be talking about that in our next video. So I hope you were able to understand it. You got a feel for it by doing some examples. So if you did, please consider subscribing to my channel, like this video, and share it with your friends. And, wishing you all the very best for your upcoming exams, and, all the very best. Thank you so much.